In this circuit, this switch has been at position A for a long time. At time t equals 0, the switch moves from position A to position B. We want to find the voltage across the capacitor, V of t, at t equals 0 minus, t equals 0 plus, and as t goes to infinity. First, let's look at t equals 0 minus. The conditions for t equals 0 minus is that the switch has been at A for a long time, and the input to the capacitor during that time is constant. It's 6 volts. Under these conditions, the capacitor looks like an open circuit. So the circuit of interest is a 6-volt source connected to a 6-ohm resistor, a 3-ohm resistor, a 12-ohm resistor, and the capacitor looks like an open circuit. The voltage we're looking for is V at 0 minus across the capacitor. Since this looks like an open circuit, the current through the capacitor is 0. That means that the current through the 6-ohm resistor and the current through the 3-ohm resistor are the same. These two elements are in series. And the capacitor voltage is the same as the voltage across the 3-ohm resistor. This is a good application for a voltage divider. So V at 0 minus is equal to the total voltage, 6 volts, times 3 ohms over the sum of the two series resistances, 3 ohms plus 6 ohms. So 1/3 of 6 volts is 2 volts. Now let's take a look at V at t equals 0 plus. Capacitors' voltages can't change instantaneously. That means that the voltage at t equals 0 plus is going to be the same as the voltage at t equals 0 minus. So that voltage stays at 2 volts. As t goes to infinity, the switch is now in position B. It's been at position B for a long time. And the input to the capacitor is this 3 amp source, so it's a constant input. Under these conditions, the capacitor again becomes an open circuit. So the capacitor looks like an open circuit. This voltage is V of infinity. I have a 12-ohm resistor, a 6-ohm resistor, this 3 amp source, and this 3-ohm resistor. Again, since the capacitor is an open circuit, this current is 0. This voltage is going to be 0 volts, and all of this current goes through the 6-ohm resistor. The voltage across this resistor, since this voltage is 0, is the same as V at infinity, and that is going to be 3 amps times 6 ohms. So V at infinity is equal to 3 times 6, which is 18 volts.